In November 2007, there was a great flurry of press activity around the announcement that stem cell researchers Shinya Yamanaka and James Thompson from Kyoto University in Japan and the University of Wisconsin in the U.S. had developed a method of deriving stem cells from human skin without the use of embryos. Many wondered whether these induced pluripotential stem cells might finally resolve the Bush administration's embargo on federally funded progress in the field. As you'll recall, on August 9, 2001, the federal government announced that research on human embryonic stem cells created before this date would be supported by federal dollars, and research on lines created later would not. By 2004, there were 21 lines of federally approved stem cells and 128 new embryonic stem cell lines around the world that didn't qualify for support by the National Institute of Health. The field of embryonic stem cell research is now 25 years old, but it's moving at the speed of light. Mouse embryonic stem cells were first isolated in 1981. But over the following years, scientific questions and ethical concerns advanced side by side. The 21 federally approved stem cell lines that existed in 2004 were fundamentally flawed and had limited potential for use in clinical therapy. As Dr. George Daly of Harvard Medical School said at the time, quotes, "All were cultured in contact with mouse cells and bovine serum, which renders them inferior to newer lines derived under pristine conditions for potential therapeutic applications. Moreover, given the limited genetic diversity of these lines, transplantation of their products would face the same immune barrier as organ transplantation," close quotes. Experts at the time generally agreed that the most important clinical questions couldn't be answered by the federally approved stem cell lines. Using these lines, one could only explore generic questions about human embryonic stem cells like what are the optimal culturing conditions, and what factors promote growth and differentiation, and how do genes modify and express themselves. But the more important questions could only be addressed by means of lines that model specific diseases. Pursuing therapies required uncontaminated stem cells with lines genetically matched to the specific therapy needs of patients with diseases like neurofibromatosis or Marfan's, or Fragile X syndrome, or myotonic dystrophy, or Fanconi's anemia. What followed was significant interest in overseas ventures, unencumbered by U.S. restrictions. U.S. states saw an opportunity as well and acted on it. By 2004, 30 states had generated 78 bills relating to stem cells. 9 states had legislation to approve state funding of the research, and California, Missouri, New Jersey, Rhode Island, they all had moved forward with concrete plans. Universities were engaged. Harvard committed $100 million, Stanford $12 million, University of California $11 million, and the University of Minnesota $8 million. They did so with considerable support from the major U.S. medical and scientific organizations, including the American Medical Association, the Association of American Medical Colleges, the Institute of Medicine, the National Academy of Science, and 125 other U.S. medical, scientific, and patient advocacy organizations, who first publicly voiced support for federal funding of research using human pluripotential stem cells way back in July of 1999. Now, Dr. George Daly captured what many medical and scientific leaders believed to have been the current reality at the time. First, that the Bush administration approach had severely curtailed opportunities for U.S. scientists to study the stem cell lines that had since been established, many of which have unique attributes or represent invaluable models of human disease. And second, that as research struggles forward in the absence of federal funding, the number of embryonic stem cell lines will continue to grow, creating ever more valuable tools that are out of the reach of U.S. scientists. In June 2007, President Bush, for a second time, vetoed legislation that would liberalize the stem cell restrictions. In spite of this, the U.S. scientific community has remained engaged. Over the past few years, $190 million have been invested privately in embryonic stem cell research. Nonprofit foundations like Project ALS and the New York Stem Cell Foundation are targeting specific diseases such as ALS, leukemia, Parkinson's disease, and diabetes. And states like Connecticut, Maryland, Illinois, New York, and California have funded experiments in progress. What about those cutaneous cells? Will they replace the need for embryonic cells? Not according to Richard Murphy, who's the president of the California Institute of Regenerative Medicine. He says, quotes, "We still think embryonic stem cells are the gold standard." Why? Because the process that creates the cutaneous cells introduces man-made viruses into the cells that carry 4 genes that reset the cell's machinery. And it's not known whether the introduction of these altered cells into humans might induce runaway cancerous growth. As Harvard University stem cell biologist Kevin Egan says, quotes, "They are genetically changed in a way that should make us worry. Human embryonic stem cells will be better, even if they are more complicated politically," close quotes. Now, with the breeze of political change in the air, it's time to redouble our efforts in stem cell research and fully support U.S. scientific leadership in this field. For Health Commentary, I'm Mike McGee.